Hello everyone, my name is Vivin Abram and in today's video we will talk about Ohm's law. So let's get started. So first question that comes our mind is what is Ohm's law? Now before I answer this question, one condition that you have to always remember when we are talking about Ohm's law, right? So whenever Ohm's law is talked about, we always have to remember that the physical condition should remain same. Right now, when I say physical condition, what does that mean? That means the temperature, right? It can be your temperature, it can be the pressure, it can be the dimensions of the material that we are talking, right? So when the physical condition remains same, then only we can apply Ohm's law, right? Okay, so now you guys can see a simple image here. So basically a simple circuit, right? So I have this bulb connected with a battery source having positive and negative terminal, right? So what is going to happen here? Yes, you have guessed it right. So what is going to happen? Because from the positive terminal, the current will flow like that, right? Yes, right? And obviously the current will complete the circle, right? All right, so as the current flows, what is going to happen? Yes, you guys can see this yellow lines are showing that the bulb will glow, right? Very good. Now I would like you guys to give you two scenarios here and you have to answer me what is going to happen in both the scenarios, right? Let's say obviously this battery will be having some potential difference, right? This battery is actually maintaining a potential difference across this this bulb. That's why the current is flowing, right? So let's imagine I'm actually talking about two scenarios here. Scenario number one, the potential difference that battery makes across the bulb is some 1.2 volt, right? And the second scenario, let's say the potential difference across the bulb is some approximately, just a simple example, 10 volt, right? So I have two scenarios. One is 1.2 volt, another one is 10 volt, right? Now I would like you guys to answer in which situation the bulb will glow brighter. Yes, your answer is correct. In 10 volt situation, the bulb will glow brighter. Now why is that? That is the question. Why the bulb glow brighter for 10 volt power supply? See, the answer is pretty simple, because what is going to happen as you make a very strong potential difference across, for example, let's say all the positive potential will be in this particular side, all the negative potential will be in this particular side. So as you make a very strong potential difference between this bulb, what is going to happen? More and more charge will flow. Is that a yes or no? So as the charge flow will increase, so does the current. Current is charge per unit time. So as the charge flow increase, the current increases, and as the current increase, the brightness of the bulb also increase, right? Power increases and power is proportional to your brightness, right? Is that a yes or no? So there is some kind of relation between your potential and current, right? So which we will figure out. So stay till the end of the video, right? Okay, now this is a little bit complicated image of your this simple circuit. So basically what is this? So you have a circuit here, you have a battery here, right? And this battery is connected with the ammeter. Now what is the work of an ammeter? Ammeter is a device which can measure the current, right? So this device here, ammeter, can measure the value of current, right? On the other hand, this this zigzag symbol thing is the conductor, or you guys can simply assume it to be the bulb, right? Just simple bulb, right? We'll talk about what is this R, we'll talk about in a moment. Now what is this? This is actually the key, right? This key is like a switch, right? You can switch it on or you can switch it off, right? You can complete the circuit, you can break the circuit, right? So this key is simply, you can assume it to be a switch, right? A normal switch that we use in our homes, right? We switch it on and the fan works, and switch it off, the fan does not work, right? Okay, so you guys, you have to understand there is this bulb over here and there is a device parallelly connected with the bulb, right? This device is what you call as your voltmeter. Now this voltmeter is again an electrical device which can measure the potential difference across your whichever electrical appliance you actually connect. So for example, if it is bulb over here, so it can measure the potential difference across the bulb. Is that a yes or no? So basically it is just again a simple circuit, but right now I have some additional components here. I have a key over here, I have ammeter, I have voltmeter. Now why I have all these devices? Ammeter can measure the current, V potential, or the voltmeter can measure the potential, right? All right. Now this is being observed that the current that is being flowing through your bulb or through your conductor, whichever way you put it, right? The current that is flowing through your conductor is found to be directly proportional to the potential difference applied across it. And this is what your Ohm's law is. So I'll just simply write it. So current flowing through a conductor is directly proportional to the potential difference across it, as long as the physical condition remains same. Obviously, the first and the foremost rule, the physical condition should remain same, right? That means the temperature across this particular region should not increase, right? The length of the wire should not increase, right? The pressure, there should not be any other external pressure to this particular circuit, right? So all these things should remain same. So when all these situations remain same, so what happens? The current that is flowing through your conductor or through your bulb or whatever device which you want to connect, right, is directly proportional to the potential difference applied. So basically this is an observational result. So basically I can actually measure the value of current over here, and I can actually measure the potential difference across my conductor. So that is the purpose of here, right? So what is your Ohm's law? Ohm's law is pretty simple. It is, see, obviously the example which we saw here, right? So obviously we had a higher potential difference, right, across the bulb, and because of that the bulb was glowing brighter, right? So that means the potential is increased, the current will also increase, right? So obviously that is what Ohm's law is stating. The current flowing through a conductor is directly proportional to the potential difference across it, as long as the physical condition remains same, right? So obviously mathematically I can write current is proportional to the potential difference across the conductor, or you can simply write it vice versa. So V is proportional to I, right? Both are same, right? Because they are directly proportional, right? Okay. Now we all know whenever you take out the proportionality sign, there is always a constant you have to add, right? So this proportionality sign has been changed to a equality sign, right? So when you do that, you add a constant. Now this constant is what we call as the resistance, the famous resistance in our Ohm's law, right? So what is this resistance? Is actually the constant of proportionality. Now what do we actually mean by resistance? It is actually, resistance actually means the hindrance, right? Now resistance means the hindrance provided in the flow of current. So obviously whenever you have a bulb or any external device which is connected with the circuit, now this external device make it harder for the current to flow, right? It always offers any kind of resistance. Obviously this wire which we have connected, right, this wire will also offer resistance, but when you connect an external device, for example you have a bulb, you have a capacitor, or any electrical device which is connected with the circuit, that device will offer a higher resistance. Now when I talk about resistance, you have to understand, you can imagine resistance to be something like, for example, you are running a marathon. Imagine that you are running a marathon, right? And let's say there are like lots and lots of people who are like coming from the other side, right? So when you're running a marathon, normal case is that on the other side there is nobody coming, right? But imagine there are like a lot of people coming from that side, right? So when there are a lot of people coming, what is going to happen? When you start running, you will feel resistance because of the people that are coming, right? So you have to change your direction, and you have to move here and there, and you have to complete the race, right? Very similarly, resistance, you can imagine it like that. So the resistance is the hindrance offered in the path of your current flow, right? Is that a yes or no? Right. Okay, so we got to know what is a resistance, and we know the Ohm's law, that is V is equals to IR, right? Now let's try to actually understand, let's try to actually derive Ohm's law with the help of the things which we have already studied in our previous videos, right? So obviously let's say I have this conductor over here. This conductor has some L length, right? And let's say it has some area of cross section A, right? It is connected with a battery which let's say it has some potential difference V, right? Now in our previous video, for all those who have watched my previous videos, so from there we can actually talk, my current can be written as Vna, right, where Vd is your drift velocity, right, and E is your charge on your electron, N is number of turns per unit volume, and A is the area of cross section, right? And on the other hand, you can talk about potential drop across your conductor is given as electric field multiplied by the length of the conductor. So these all things we have discussed in our previous videos. Feel free to go and watch my previous videos to understand this, right? So I know the current can be given as VDENA. Again, further VD can also be further written as, let me just write down, VD can also be further written as E, capital E upon M multiplied by tau, right, where E is again your, E is charge on electron, E is electric field, M is the mass of electron, tau is the relaxation time, right? Okay, so all you have to do is you have to divide equation number 2 with equation number 1, right? So divide equation number 2 with equation number 1, you will get, and put the values over there, and you will get, so basically here I have put the value of drift velocity also. So when you do that, the electric field will cancel out, and you will get V upon I as M L E square N tau A. Now you have to understand, in our Ohm's law equation, if you remember, V is equals to IR, or I can simply write V upon I is actually a constant, that is your resistance, right? So here also you guys can see V upon I is actually coming out to be a constant. Is it a constant? Let's try to understand. M is the mass of electron. Mass of electron is a constant quantity, right? Length. So as it is being said, you are not changing the physical condition. So the length of your, you know, of your conductor is actually same, right? Okay, E square, where E is your, you know, charge on an electron. Now charge on an electron is going to be a constant, it will not change. N is number of electrons per unit volume, right? So number of electron per unit volume is again going to be a constant for a physical, for a constant physical condition, right? Tau is relaxation time, again the time between any two successive collisions, right? Again this time will going to be constant because we are not changing the physical condition. Again this is area of cross section, again you are not changing the dimension, so this will also remain same. So you guys can see this entire term is actually a constant, which we call as a resistance offered by the material to the current. Is that a yes or no, right? So obviously it is a constant for a particular physical condition, right? And we can also say resistance is equals to the same thing here, resistance is equals to M E square N tau. So you can actually change the length of a wire, you can actually change the area of cross section of a wire, but again this middle term, you guys can see M upon E square N tau, this is a intrinsic property of the material, which we call as our resistivity. So from here we get this formula, R is equals to rho L by A, where rho is actually the resistivity of the material. So for example, if you have a copper material, right, so it does not matter whether your copper material is like L length long, or it is like it has a big area of cross section, the resistivity of the material, whether you take a small copper wire, whether you take a big copper wire, resistivity will be same. But anyway, we'll discuss resistivity in our coming videos, but I hope you guys can understand what actually is Ohm's law. So what is your Ohm's law? Under a constant physical condition, right? Let me just make, give you the diagram here. Yes, the diagram is here, right? Under a constant physical condition, the current flowing through your conductor is directly proportional to the potential difference across it. I hope you understood the video. If you have any doubt, you can comment it down in the comment section. And for all those who are like first time for the channel, do like, share, and very important, do subscribe the channel. That's all for today. Thank you and have a nice day.